Hello and welcome to another episode of Risky Business. We're going to continue looking into this UART stuff. So we were looking at this UART init last time, and so we want to know the actual definitions of all the stuff we're seeing in here. We saw that this matches. Let me open up Milton here. So yeah, we did the algebra, and we saw that this is the correct equation to get the appropriate div value. And then these two lines, we know what they're doing just because we've seen the GPIO IOF select and enable already. We saw those when we were researching GPIO and learning about the LEDs. So I guess apparently the UART uses the multiplexing of the GPIOs. So you need to select that you want UART and enable it and stuff. And then we're setting transmission enable in the control register. So that makes sense. That's setting it up so that we can transmit over the UART. I imagine if we wanted to receive from the UART, we would also need to enable that in the control register as well. And then of course we know what this loop is doing too. We saw that a while earlier actually, and Megan explained it to us on the forums. So we just need to know the actual definitions of these things. So first of all, if we go to the SiFive 1 Getting Started guide, I think that should probably detail what we're seeing in the iOS 0 UART 0 mask. I think that should be specified in the Getting Started guide, because that's where it was specified, if I remember correctly, for the LEDs, the different color channels. So I'm expecting to find that in here somewhere. Okay, so this is what I was talking about. You see how with LED there was the green, blue, and red, and it said that you need to be on IOF 1 for these specific pins, right? And here you can see the actual pin numbers and the GPIO offsets. So we see on iOS 0, we have a UART 0 receive and a UART 0 transmits. And that's pin number 0 and 1, GPIO offset 16 and 17 respectively. So let's go in the code here. Let's see, I don't need this open. And I'm going to move this over here. And so we want to find the definition of IOF 0 UART 0. So that's actually going to be over here somewhere. Or wait, no, it's going to be in here somewhere. UART 0. So I don't think it's going to be defined in this one. Maybe platform.h. Okay, well, here's a UART0 base address, but that's not what we're looking for right now. Here we go. So here's an IOF0 UART0 mask, as well as the receive and the transmit. And we see that this is set to 16 and this is 17, so that would be the GPIO pin 16 and 17. And that's exactly right. One thing that's interesting to me is that we see a UART1 in the code, and 24 and 25. I wonder if that's for like the RD dev kit, because I don't believe the SiFive one has those. But yeah, this much of it makes sense, or I mean, these two lines. So then, if we go back to the init, so wait a minute. For GPIO, select and enable, we're using the IOF0 UART0 mask. So this right here, this value. So let me see here. So I'm a little bit confused by that. We're actually setting that mask, like we're turning that off in IOF select, and then we're setting that with IOF enable. Like we're setting it on with IOF enable. So I think I maybe need to review the GPIO IOF select and enable stuff. So we're probably going to want to look at this manual, maybe. So the chip itself has two UARTs. But we're just using one of them on the SiFive 1, if I'm understanding correctly. So GPIO, we want a refresher. So the hardware I/O functions. It says that each GPIO pin can implement up to 2 hardware-driven functions, and you enable with the IOF enable register, and the IOF that you used is selected with IOF select register. When a pin is set to perform an IOF, it is possible that the software registers, port, outputs, pull-up, etc. may not be used to control the pin directly. So, I mean, it makes sense that we'd be turning a bit off here, because if we say the UART0 mask is going to have a 1 bit for the one that we want, right? We want IOF 0, which would mean actually turning that bit off in the register. So I think it makes sense that we're doing this. It's just the value that we're using that I'm a little bit confused about. So what is the layout of the IOF select register? I suppose it's just like 32 bits, right? And then it maps to each GPIO pin. So let me see here. So like if we say the top end of it is unused and the bits 0 to 23, each one indicates one of these, then it's either setting this bit, or both of them. The value in hex that we see was a 3 somewhere in the middle. So, you know, if you were counted off 1, 2, 3, so that's going to be 2 bits that are on, that are adjacent to each other. So presumably it's doing bit 16 and 17 within the register, and we're turning those 2 bits off. We're making sure they're off because we want IOF 0. If they were on, it would mean IOF 1. So like when we were doing the LEDs, we wanted these to actually be on. So because they're on IOF 1, we actually set those bits on in the GPIO select register. But I don't see a thing that's actually telling me that I'm correct about the layout of the register. I'm just assuming that based on my past knowledge, and, you know, it makes sense. We could look it up in the previous Risky Business episodes. So I'm gonna check the Risky Business episodes. So let's go to github.com/ what is it, like Risky Business annotations. And like, let's just search IOF and see if anything comes up. So it looks like we covered IOF in episode 27. So we start reading about it at 21:10. And it goes to 33. I don't know if that's actually going to cover what I'm thinking about, though. Well, let's go to risky.tv. And we'll play it in the background while we look at other things. I won't connect the audio up for you guys, since that wouldn't be very interesting for you. So yeah, we're gonna jump here, and I'm gonna listen to this while I do other stuff. Why does scrolling take me to that edit page? That's not very convenient. All right, and while that's playing, I want to So I want to go and look at the ones for the LEDs, because that'll help refresh my memory as well. So I'm not seeing the ones I'm thinking of. Let's go to the LED fade demo and take a look at what the code was doing again. So the green, blue, red offsets. Oh, here they are.
So, when you say the schematic of GPIO, is this something like I don't know if GPIO is standardized outside of like what we're doing here. I know this is all compatible with Arduino, but I don't know the hardware background of this. When you're talking about the schematic of GPIO,
So, okay, here we go. The GPIO offset 19,
the risc-v documentation,
21,
that was, but like this one right
22,
or
and then
about like
when you look in the code here, you see
specification
19, 21, 22, right?
because like is there a technique
So that is how it works. It's what I thought.
so this guy right here
So then if we go back to the init and then we go to
reason
platform,
that
I'm going to close this since I no longer need it. We don't need this. Okay, so here's what I'm thinking. Where did we have the UART? Here it is. So this is the value. So if we take a look at this value here, I guess I don't need to do any conversions on it, do I? Because we know that 3 is 2 1s right next to each other. So this is 4 bits, 8, 12, 16, and then this is going to be like the 17 and 18. So are they 17, 18? They're 16, 17. So I'm maybe off by 1 in my counting. Let me see here. So like, well, if we think about it the way I'm thinking about it, it is like we want to have the offset and then we say 1 shifted left by that value to get you to a specific number. But we just have a mask. So I'm trying to think of this mask in terms of what you'd shift, right? To make sure it matches what I expect. So let's convert it to binary. Okay, so like if we said 1 shifted 1 place, that would get you to the second bit, right? So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 16, 17. So the offsets are 16 and 17. You can count it off in binary if you count to where these places are, where you say like this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11, 12, 13, 14, 15, and then you see this is 16, this is 17. So that matches up with the GPIO offset that's documented in the documentation. Personally, if it were me, I would not have made a mask for these two together. I would have just had like a UART0RX offset and a UART0TX offset, which would be defined to 16 and 17. And then in the code, it would be a lot clearer, in my opinion. So let's go to init.c. So in this code here, it would be a lot clearer if this were written with a IOF0 UART 0 transmit or TX offset, and then you know, the same thing for the receive, and then you just like OR them together. So like it would be like this. Right. And if you look at the demo GPIO, or I mean the LED fade demo, you see that's how this works. I guess they parenthesize it. I don't know the order of operations here. I think the OR would happen before the shifts, but maybe I'm wrong. So like this is what you would do, because when you shift this into place and you shift this into place and you OR them together, that's going to give you the same value that the mask is defined to be. And then you invert it and equal with that, and that makes sure to turn off those 2 bits in the IOF select register. And I think that is a whole lot clearer, because it then, you know, you say, okay, I want to see what the RX offset is defined to be and the TX offset is defined to be, and you look it up and it's like, oh, it's 16 and 17. Let's check the documentation. It says 16 and 17. We understand it, right? But if you just have in the code a mask that's just like a bunch of zeros and a 3 in the middle, it's like, well, what's that? You know, you actually have to figure it out that it's what you want. So that's just my little critique of how this one was set up compared to the LED offsets. I think the LED offsets did a better job of clarity of code. But anyway, now that we understand this stuff right here, we just need to understand this stuff right here. And one thing that's interesting about this is this actually calls a get CPU freak. So we're actually going to see how we are calculating the CPU frequency. So let's just take a quick look at that. This is the get CPU freak function. We define a static uint32 called CPU freak. So for those of you who aren't familiar with C, I'm not an expert in C myself, but I believe this is creating a static variable. So it's like a global variable basically, but it's only scoped within the function. So it persists between function calls, but you can only access it inside the function itself, is what that syntax does. So basically the first time through, it's going to say, if not CPU freak. And I think this is a bug, right? Because this should be defined to equal 0, because in C, well, maybe static variables do get initialized to 0. I guess I'm not sure. Global variables do, because they go in the, I think it's called like the BSS section of the executable, and all that memory gets initialized to 0. I don't know if that's true of static variables or not off the top of my head. I'd have to look that up. If it is true, then this is fine as it is. If it's not true, you want it like that, because normally, like if you have a local variable, if this didn't say static, right, the value of this is undefined. It's garbage. It likely won't be 0. Totally depends on like what's on the stack, right? But because it's a static, it might actually get initialized to 0. So I kind of want to look that up right now. I know this is a digression, but it's important to know, I guess. So does static variable inside function get initialized to 0? So this is C++, not C. But apparently in C++, the constructor gets run the first time the function is called. But I'm thinking about... And again, here they're quoting the C++ standard. Maybe we should look it up in the C standard. So I don't think Stack Overflow is going to save the day for us here. I have a printed copy of this C standard somewhere around here. For now, let's just Google it. So C11 standard draft. I don't know if we're compiling with C98, C11, or what. We could check in the make file. Let's go over to demo GPIO. Let's just cat the make file. So that did not specify. Let's check the common make file. What does GCC default to? I think it defaults to like 98 or something. So I don't see anything in the makefile is setting the C standard version. GCC standard version default C mode. This was 2013 though. So it doesn't fully conform. The default is equivalent to GNU 90. This is a small font for me here. Yeah, GNU 90. So 89. It defaults to the 89 standard, basically. So let's assume we're on C89 and see if we can find. So does ANSI provide a public? You probably have to buy it, right? I know you can get the draft of the latest C standard for free online as a PDF. That's what I printed off. Let's just search C89 standard PDF. All right, is this C89? This document was lacking a cover, and the thing just gives the ISO code. It says it's a committee draft from 2007, and it gives the paper numbers. Well, let's search around in this document and see what we find. I don't know if this is exactly what we're looking for. Well, let's go to openstd.org. That's the site that we're getting this from. So we care about C. So we've got various mailing list stuff. So 9899, programming language C. We have extensions. .9899 is the current C standard, C11. So So there's some various stuff about C99, and there's the C11 draft. So let's just grab this one. We'll just look at C11 and hope the behavior has not changed, which it probably has not. So let's just search for static and see what comes up. So I believe we're talking about static storage duration. So according to the C standard, its lifetime is the entire execution of the program, and its start value is initialized only once prior to program startup. So I think in C it maybe is treated the same as a global variable. That's some interesting syntax that I didn't know about. This apparently gives you a modifiable string literal that has automatic storage duration, so like it's a local variable. If I'm reading the standard correctly. So what I'm wondering is, are all static storage duration variables guaranteed to be 0 initialized? Because I know globals are. And as far as the standard goes, I'm pretty sure that it just groups that in the bigger category of static storage duration. But I'd like to see actual clarification of that. I know I'm being pretty pedantic here, but it's the difference between this being correct and this being a bug, which is actually kind of important, right? Because if it's not guaranteed, this could be initialized to whatever garbage happens to be there. And then this could fail. Because what we're doing here is memoization, right? First time it runs, it measures the CPU frequency, and then after that, it just returns the cached value, right? That's known as memoization. And that's going to fail if this is not initialized to 0. So we actually need to care about what the standard says here. So here we're talking about initialization for statics. But it's not exactly what I'm looking for, because here we're talking only if you initialize it. I'm wondering about default initialization. Okay, J.1 says under unspecified behavior, the following are unspecified: the manner and timing of static initialization. So it's not undefined behavior, it's unspecified behavior. So I think it's up to the platform to define the behavior, and I believe Linux would be responsible then for defining this to be 0 initialized. Although in our case, the platform isn't really Linux, it's bare metal. So I guess I don't know what the conventions of our platform are in that case. So let me go back to where we saw that. 5.1.2 is what it references, so I want to find 5.1.2. Okay, so 5.1.2 is execution environments. There are two defined, freestanding and hosted. Freestanding meaning bare metal in our case. It does say all objects with static storage duration shall be initialized set to their initial values before program startup. The manner and timing of such initialization are otherwise unspecified. So in a freestanding environment, which is, like they say, bare metal, the name and type of the function called at program startup are implementation defined. Yeah. Library facilities, other than the minimal set, are implementation defined. Program termination is implementation defined. So it might be a good idea to ask this on the big risky business thread, because according to the C standard, this is going to be implementation defined. So we need to confirm with SiFive that their implementation 0 initializes variables with static storage duration. And I'm sure like you can find that in the GCC stuff for risc-v, but I really don't want to look for that. Where's my Linux book? Because I know in Linux it's 0 initialized. I'm going to find my Linux book. Just a second. Okay, so this is for Linux. The uninitialized data segment contains global and static variables that are not explicitly initialized. Before starting the program, the system initializes all memory in the segment to 0. For historical reasons, this is often called the BSS segment, a name derived from an old assembler mnemonic for block started by symbol. The main reason for placing global and static variables that are initialized into a separate segment from those that are uninitialized is that when a program is stored on disk, it is not necessary to allocate space for the uninitialized data. Instead, the executable merely needs to record the location and size required for the uninitialized data segment, and this space is allocated by the program loader at runtime. So some trivia based on that is that if you explicitly initialize your variables to 0, unless the compiler is smart and changes that so it's not explicitly initialized, I don't know if it'll do that, but if it doesn't, you're just bloating your executable, because instead of it putting it into the uninitialized BSS segment, it'll go in an initialized segment where it actually stores the initialized value in the executable. So rather than storing a bunch of zeros in your executable, if you just don't initialize your static and global variables that you want to start at 0, that's a good way to save some space. But that is specific to Linux, and we are on bare metal. So I'm going to ask this on the SiFive forums. Let's go to SiFive, the big risky business question thread. Where can we find the where it is defined how variables with static storage duration are initialized? How uninitialized this must be set to use American spelling for some reason. I usually use British spelling. I don't think these should have Z's. I'm pretty sure British uses S's, but whatever. So where can we define where it is defined, or where can we find where it is defined how uninitialized variables with static storage duration are initialized for the SiFive 1? Section 5.1.2 of the what's this document? I mean, I know it's the C standard, but I want to give them the actual document number. Well, first of all, let's copy what we want to say from it. So let's make a quote here. I guess we need to paste it before we do that, apparently. Let's clean up this formatting. All right, and then we need the name of the documents. The N1570, I guess it is. Can I paste, please? There we go. So, on Linux, I know it is defined that the uninitialized ones go in the BSS segment, which get 0 initialized by the program loader, but I don't know how this works for the SiFive one, since it is bare metal. Where would I look to find out how it works? So hopefully that's clear enough what I'm confused about. And I think we're out of time for tonight. So thank you everyone who tuned in, if anyone did. And thank you everyone who watches on the YouTube archive, which is available at risky.tv. And you can follow me at HMN_risky to get updates about the series. And I will see you in the next episode. Stay risky, everyone.